All right, so today is Tuesday, May 28th. Let's write that in our notes as well. Tuesday, May 28th. Today is our day 3. So I'll say this is going to be day 3. Day 3, it is 5/28/19. All right, so we are doing lesson 1-2 because lesson 1-2 was supposed to be on Friday, but we were mini janitors for the day. All right, so let's talk about variables. Yeah, James, what's going on? Okay, I have pencils up here if you need them too. All right, so variables. Every programming language has variables, although OpenSCAD doesn't have the most sophisticated programming language. It does have variables. They need to start with a lowercase. So start with lowercase letter. So I will draw let's make 3 different variables, and you have to decide which one is a proper variable. Oh, and all has to, let's add this to, and one word. All right, so some of these might be proper variable names, some of them might not be. So let's do the variable. So these are examples, I guess. Too cool, or you know me, or let's do another variable. Mr. Sindel, all one word. All right. You are going to tell me which one is a variable, which one is not an example of a variable. Are there quiet raised hands? Yeah, Gunnar. It is a variable. So everyone write this down. This is a variable. So that's the check. All right. Who can explain why too cool is not a variable with a quiet raised hand? Colby.
Started with a number.
Yeah, it starts with a number, so that's not a variable. Give yourself 50 XP. And Mr. Sindel, why is that also not a variable, Cohen? Yeah, it's right there. It needs to start with lowercase, so that's also not a variable. Not at least for OpenSCAD. All right, and then Cohen got 50 XP. Thank you, Colby, for doing that. All right, so variables have weird properties. So let's talk about, what is it? I don't know what the proper term for it is called. Oh yeah, I'm just gonna say new value. So new values. So if you have a variable, let's do a really simple variable, a variable called x, and we say x is equal to 3, and then we do a semicolon, just like all of OpenSCAD. Now, whenever we say maybe we want a square with dimensions x, that's going to be a square that's 3 by 3. But what happens if we now say x is equal to 5? So what is going to happen? Quiet raised hand. Colby?
Did you change the value of x?
I did change the value of x to 5. Yeah, so give yourself 50 XP. So now x is always 5, which means, which is really cool, if I had a line of code up here that said square x, even though I haven't even assigned a value of x, x for our entire function, in our entire code, is always 5. This x equals 3 basically means nothing. You can basically cross that out. Your variable always assigns the last value. So if I did a square of x at the very top here, it's going to say, okay, it's going to be a square with 5. You override the x from 3 to 5. So it's always the last value. So if you want to add a comment here, variables take on last value. Variables take on last value. And then variables can hold integers, it can hold strings. Is there a quiet raised hand? Can someone tell me what the difference between an integer and a string is? Does anyone know this from a previous coding class? No? Okay, well, let's keep talking about this. So we're still talking about variables. I'll continue this on. I'm going to wait until people stop writing so I know that I'm not going too fast. All right, we are on to the next slide. So let's talk about strings. String, and we'll do integer. Yeah. All right, so a string is something like this. Here's an example of a string. Notice that it starts out with quotes and it says something inside like hello, and then it ends with quotes. That is a string. You should think of strings as words or things that you want to display as text. Integers are pretty straightforward. They're whole numbers. So an integer could be like 2. That's as easy as it gets. So kind of as a summary, integer is a whole number. A whole number, and a string is like a word. Strings are allowed to have spaces. Integers are just numbers, straightforward. We're basically only be using strings and integers. If I ever introduce a new type of variable, I'll label that. But for today, we're just doing strings and integers. We don't really need to talk about scope of variables. It's kind of more advanced. Let's talk about what's next. How to say what's going on. So let's talk about echo. 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 And I can't spell. Echo is a command. If I type in echo in OpenSCAD, it will say what's going on. So here, this is, how do I want to say this? How to check the inside of variables, or what variables contain. I'm just going to say variables. All right, so this is the part where I'm going to open OpenSCAD. You guys are just going to keep taking notes. Hopefully everyone can see OpenSCAD. Make a new program. All right, so if I do x is equal to 3, and I do a semicolon, and I run that, nothing happens. I don't see anywhere over here in the bottom right where the console says x equals 3. I don't know that x is equal to 3. But if I come down here to line 2, and I can make this come in right here. If I come down here line 2 and I say echo x, and I do need a semicolon, you can see right here, it's kind of hard to see because I can't really increase the size. It says echo 3. If I change this and I say x is equal to 5 or something like that, and I rerun it, it says echo 5 right here. If I come down here and I change x to a string, x is equal to hello, and I have to end with a semicolon, it'll say echo and then it has hello. It always takes the last value. So if I ever want to figure out what's going on with a variable, use echo. It's that straightforward. I'm done with talking about echo. Are there any questions up to this point? No? All right. So this is the part where you guys are going to tell me what happens in the console over here. So the question is, what happens in the console? Here's an example, just to check your understanding. So an example. I want you to figure out what's going to print out to the console. So I can write that out if you want. What prints to the console? This is where you're going to handwrite the answer. So I'm going to write A is equal to 5, semicolon. I'm going to do B is equal to high, semicolon. And then I'm going to do echo A, exactly like that. I want to know what's going to happen with the console. What is it going to say whenever I hit run? And I will freeze that screen and start typing so I can actually test this out. So x is equal, or I'm going to say a is equal to 5. If you know what's going to type, go ahead and do that now. What is it going to print out? What is going to happen? And I will be walking around and seeing if we have the right answer. So it was a trick question. The answer is it'll say error.
I thought that at first.
So is there a quiet raised hand? Why will it print out some sort of error message?
Because.
Gunner.
Because high.
Because high.
You didn't put a, no, I'm not. You put a semicolon. Yeah.
Exactly.
Behind it.
We did not put a semicolon. So I have that exact code written right here, echo A, and if I run this, it will say error, syntax error, something happened that was bad, and it even tells me there's a red dot here on line 3. Something happened on line 3 or somewhere around there. If I did a semicolon, then it would do something. And I'm not going to actually run it, but yes, we do need a semicolon. Okay, so now what would happen? If I did have a semicolon, what would it print out? And I saw like 4 people get it. Quiet raised hand for XP. Cohen? Yeah, so it's going to say something along the lines of echo 5, and we can see exactly here, echo, and then colon, and then 5. So the correct answer here is, I'll do that in comments, it'll say ECHO colon 5. That's what we'll print out. And that is a pretty straightforward example. Let's go on to something new. Let's talk about cylinders. So, next topic, cylinders. All right, so first of all, let's draw kind of a large picture of a cylinder. I don't want this to be tiny. I want you to be able to label this. So take up maybe 3 lines, but in terms of how wide it is, make it pretty wide. So a cylinder. And I can do my best attempt at a cylinder. There's my cylinder. I can have maybe a dotted line back here to make it look maybe more of a cylinder. Everyone draw a cylinder. So a cylinder can look like that, or a cylinder could look like this. And I know that for those of you that have taken geometry, which I believe is most of us, not Julian, not Gunnar, not Monse, and not Cohen, but everyone else has taken geometry in your, or at least, I guess everyone's taken 7th grade math too. Everyone is saying, hey, Mr. Sindel, that's not a cylinder. Quiet raised hand. What shape is that? Quiet raised hand. Yeah, go for it. It's a cone, yes. But with open SCAD, yeah, so 50 XP. With the open SCAD, that is considered a cylinder, a specific type of cylinder.
I love waiting.
Is there
I
a...
was messing with it the other day. I know exactly.
Oh, you know how to do it already?
Kind of. Not really.
Okay, well, let's write this down before I call on people. Cylinder. And again, I can just take this from the cheat sheet. So cheat sheet.
No, I was using the cheat sheet and I made it into complex.
If I come down here to cylinder, it's in 3D. So cylinder, you do H. So you always start off with H. H is the height. So we can even label it on our diagram right here. This is H. This distance right here is H. And I'll pause. How tall, what is the height of your cylinder?
24.
And then from there, you can start giving new variables. So you have the choice. You have cylinder and you have R/D. So there's actually 2 different commands within cylinder. So you can do R, D. So a bit of review for some easy XP. What does that symbol mean again? Julian. Sorry, what does that line symbol mean? You are correct that it's radius and diameter. Say again?
Or.
Yeah, or. Whenever you see a line means or. So Julian gets his 50 XP. Thank you, Colby. From there, so it's radius or diameter, and then the next thing that you're going to do is center. You don't have to do center. Center is optional. And I believe by default, center is set to false. And then, of course, you do need a semicolon because this is an object. This is not a transformation. So let's see an example of what's going on here. So if I come over here and I do cylinder, and I do a semicolon. Let's do something that's 10 tall, and let's just obviously do nothing. I'm just going to type in, let's do 4. And I run this, and you will see something weird has happened. So by default, that is only doing radius. So if I come over here, I think the default command is R1. This is the default of everything. It's now saying R1 is equal to, what do we type in here? R1 is equal to 4. So this is the same thing as if typing cylinder 10 R1 is equal to 4. That will print out the same shape. I'm going to comment this out by putting 2 lines in front of this and run the same thing. It's the same exact thing. So by default, that's saying R1 is equal to 4. Well, why didn't that print out a cylinder? It's because if I did R is equal to 4 and I comment this out, oh, R is equal to 4, Mr. Sandell, there we go. Radius is equal to 4. Now it actually makes a cylinder where it has a radius of 4. So by default, you'll be doing R1. So if you actually want the radius to be 4, make R. If you want the diameter to be 4, do D equals 4, and the diameter will be 4. All right, so coming back to our notes, what do we want to be typing here? So the default command is this one below here, cylinder. You always start off with H. You could do R1, and that's the number 1, not a line. R1, and then make the line really big, R1, or D1, comma, R2, or D2, comma, center. And I can't spell center. And then we always need to end that with a semicolon. And again, I can check that by going to the cheat sheet, and I did that correctly. Whew, I'm not teaching you wrong information. That would be really bad.
Are you sure about that?
I'm pretty sure about that. So how do I make a cone then? Well, let's go ahead and label these. What is R1? What is D1? So if I come down here, and I'll do a different color. I should be doing this in red. If I do this length, I'll do it right here. This length right here. This length right here is R2. This length down here is R1. And similarly, if I have this whole length in black, and I'll do it slightly below, that would be D2, and this whole length down here for the base, that would be D1.
Radius 2.
Yeah, so the first dimension is always going to be the base, and again, I'm using all these words and I'm not explaining them, but when I say base, I'm talking about the bottom. So base is the same word for bottom. So the base is D1, and then the top will be D2. So let's go ahead and play with that. Everyone has this down in their notes. We're going to start playing with it so you can see examples. Julian is still writing. Monty's still writing. And all right, so let's see how to play with some of these examples. All right, so I'm commenting out this code. So let's do cylinder. R1 is equal to 4. R2, and I need a comma. R2 is equal to 10. All right, so I want you to now write this down in your notes and sketch. What is it going to look like? Sketch. What is this going to look like? Where I have a cylinder, 10, R1 is equal to 4, R2 is equal to 10. I'm going to be coming around and checking. All right, so here's the answer to what the shape should look like. It should look like something with a top radius that is 10. And then if I type in Fn is equal to 100, it does in fact make it smoother. And I can make it even smoother by making this go up to maybe like 500. Boom. Oh, so smooth.
That's a smooth,
Silky smooth.
triangular cylinder I've never seen.
What about 3,000?
What about 3,000?
All right, so here's the next question. What is going to change if I go like this? So everyone has this in your notes. What is going to change if I do D1 is equal to 8 and D2 is equal to 20? Quiet raised hand. What is now going to change from this code to the one that you had? If I hit preview, what is going to change? And you can say the top will get bigger, the bottom will get smaller. What is going to be changed?
They're gonna be even.
Quiet raised hand. What is going to change? Since there are not enough hands, I'm going to do a think, pair, share. Talk to people around you. Talk to people around you. See if your partner has the same idea. This is going to be like a group of 3, I guess, right here. Talk to people around you. Cohen, Gunner, and Julian, you guys talk. What's going to change?
So double the size. It's gonna double the diameter.
All right, now quiet raised hand. Who has the answer? What's going to change? Gunner.
It's gonna double the diameter of the top.
Double the diameter of the top? Good guess, but no.
That's HP.
Colby?
It's gonna say exactly the same.
Say exactly the same. That's the answer. So he gets 50 XP. Okay, why?
Gunner gets 12.
Our old code said that the radius was 4. Well, I guess this is a bit of geometry review, and if you haven't been in my geometry class, I won't hold you accountable. But yeah, so radius is half the diameter. You have it in your notes here. The diameter is twice the radius. So if I come back in my code and I say the diameter is 8, that's the same thing as saying the radius is 4. If I say that the diameter is 20, that's like saying that the radius is 10. If I click preview, the same exact shape. So it's the same code. All right, so what's going to happen now if I change this to D is equal to 35? And I'm going to leave this Fn is equal to 500 to make it nice and smooth. I want you to do a rough sketch of this code. So I want you to write down this code once again and do a rough sketch. What is going to happen when I have cylinder 10, D is equal to 35? Do that now. All right, and here is the answer. Boom! It is a cylinder with a diameter of 35. This whole length here is 35. Okay, your last challenge is to write code. I've been giving you code and you've been making shapes. I'm going to give you a shape and you need to tell me how to make that code. So I'm going to freeze the screen so you don't get to see the code. How are you going to make the following shape? And I will give you the dimensions in a sec. So get ready to draw a shape in your notes. All right. All right. And let's go to our new slide down here. Please stop. That's really annoying. All right. I will tell you the dimensions. So this height here, it's kind of hard to see. But this height right here is, oh shoot, what did I forgot my dimensions. It is 25. This diameter right here is 15. That's all you need to know. You have the X, Y, and Z. What is the code that will generate the shape? All right, so there's the answer. I did kind of make a tiny mistake. I called that R instead of D, but whatever. There is the general shape. It's really interesting if you don't have a condition right here and you preview this. By default, the radius is set to 1, so this diameter up here at the top is actually 2. So you do indeed need to say R1 or D1, doesn't matter, is equal to 0. And then from there, it actually makes, oh, there we go. You make D2 equal to 0, not D1. So by default, cylinders are centered around the Z-axis. I'm losing control of this class. Do I need to take 10 HP from everyone? I hope I don't. So by default, you are centered around the Z-axis, but if I want to be centered around the X and Y-axis as well, that's where this center is equal to true comes in. So if I do center is equal to true, then it's perfectly centered for everything. If I do center is equal to false, which is the default, or if I just type in false here because that's the next line, I don't need to say anything, that by default will make this centered around the Z-axis but nowhere else. James, that's HP. I gave us all a warning. All right, so that is cylinder. Let's move on to our next thing. Does anyone need new notes? Because we're going to do 2 to 3 pages of notes today. If anyone needs new paper, grab it now because we're about to continue on. All right, let's see here. Next on our agenda, we have a text. That's kind of an important one. Text. So, text is kind of cool because I want to know how to engrave and how to emboss text. So the general text command is text. It's that straightforward. And there are a ton of things that go into text. So don't have a parenthesis right there. Our end parenthesis is going to be like down here on the bottom right because there's so many commands for text. If I come back here to my cheat sheet, so text. That is in 2D. Notice this, a two-dimensional object, not a three-dimensional object. Here's text. The first thing that you're going to do is T. T stands for the actual text. So T, and we'll make a note here that T is equal to the text that you want in there. So I'll do an example in a sec, but T is the text that you want. So if you want to say hi, replace this with in parentheses, like quotes, hi, or something like that. The next variable that we're going to need for our text is the size. And I'm going to write the defaults above that. The default size is 10. And the size is actually how tall it is in millimeters. So if you want your text to be 10 millimeters in height, that is going to be size equal to 10. So if I come out here and I write hi, this distance right here is 10. That's going to be called the size. And that, again, is always measured in millimeters. In order to figure out the length of your text, there is a really simple program to do, but for now we're only going to be changing our text by the height. The next thing that we have for our text is going to be called, is it going to be the center yet? Okay, font. You have a bunch of different fonts. Anything that's on your Mac you can use on OpenSCAD. So if you install a new font, you can use that new installed font with OpenSCAD as long as you restart OpenSCAD. Next, I think, is H-align and V-align. Is that right? Yes, H-align. This is the horizontal alignment. So I'll write that above here. By default, it's set to false, so I'll put false. By default, it's set to false, but H-align stands for horizontal. H-align means horizontal. So if you want it to be centered in terms of the horizon, again, horizon, you can think of that as the x-axis. So if you want to be centered in terms of the x-axis, you'll set H-align equal to center. You won't set it to true, you'll set it to center, or you can set it to left or right. All right, then we have V-align, which I think we can guess. Quiet raised hand. What is V-align? If I can spell it correct. V-align stands for what? Quiet raised hand. Only 2 people know what V-align means after looking at H-align. Cohen? Vertical alignment, yeah. Probably that's 50 XP to Cohen, thank you. Yeah, vertical alignment. And again, by default, that is set, okay, it's set to bottom. I actually don't know what different things are in here. I'm realizing now that I made an error, and it's not the biggest error, but this shouldn't be called false, it should be called left. The default is left, not false. Oftentimes, we will want to change this to something like center. V-align, I'm going to guess by default it's set to center. No, I'm going to guess bottom or something like that. Let's go ahead and learn more about how to use the cheat sheet really quickly. So if I actually click on this, it is a hyperlink. If I click on text, it'll give me a bunch of examples, way more than I want to put in my notes. So H-align, it's a string. Yeah, so you have left, center, and right, and V-align, top, center, and bottom. Yeah, so by default, it's set to bottom. And I'm just reading right here. If I zoom in here, V-align, you can have top, center, baseline, or bottom. It might be set, oh, sorry, default is baseline. My bad. Default is baseline, which is different from bottom. I'm not exactly sure how baseline and bottom are different. I don't know if it matters that much to us, but baseline. Oh, I know the difference, because if you have your baseline and you have letters that go underneath your baseline. Bottom would be the bottom of the Y. Baseline would be the baseline of your letters. I'm pretty sure that's the difference. Anyway, let's get rid of that. More things to do with text. If I come back here, back to command 0. None of these other things we really use, so I'm just going to kind of end it here. Direction you might use once in a while. Language and script, you don't really use those, so I'm going to go ahead and end it right there. Those are the ones that we'll be using over and over again. So let's do an example. Yeah, please stop. So an example. So let's engrave moo. So I'm going to do text. In quotes, moo. I want to make that really big, 100. Or 1,000. No, let's do 100. And then I'll do center, and that will be it. That is an example for some text. Do you want to see what it looks like? I will freeze this so you guys can keep writing it down while I type this. All right. I will unfreeze this as I'm typing in text moo 100. Ooh, I think it does need to be a string. Center. Is there anything else? I did put it as a string. Okay, cool. Text moo center. Okay, and you'll have this as well. Every single time that you use font, it'll take a while to update the fonts. If you've never used fonts before, that'll take like 5 minutes. But there it is, moo. And if I change moo to Mr. Sindel, you can have spaces in there. It will come to Mr. Sindel, zoom to size. There it is. And I think the default font is Arial. I would have to guess just by looking at this. You can, of course, change the font to something that looks cooler. You'll notice here that I'm previewing each time. If I were to actually render it, it is two-dimensional. It's green. If I zoom in here, you can see those lines. That means it's two-dimensional versus a preview, which looks more solid. That preview has width, but it needs to be three-dimensional. So the next logical question is, how do I make this three-dimensional? We know that we're not ever allowed to combine 2D with 3D. You always can do 3D with 3D, right? So how do I make this 3D? And the answer is, before that, you are going to modify it with a modifier called linear extrude. And if I change that to like 20, it will make it stand up by 20. If I change that to 30, it will make it come up to 30. So linear extrude. Let's write that down in our notes as well. Let's come down here to, I'm running out of space here. Get rid of you. So linear extrude. Let's make this blue. Linear extrude. You can use it for a bunch of different things, but in general, it converts 2D into 3D. There is rotate extrude also, which can make some really, really cool shapes. But in general, it just kind of stretches things. It pulls it into the third dimension. So that's how I'm going to explain it. Pulls up into the third dimension. And your example looks like this. Ooh, before we do the example, sorry. We need to see what it actually does. So it's linear underscore extrude. And then the thing that goes in here, what are they calling it in the cheat sheet? Let me come back here to the cheat sheet. Linear extrude. Where are you? Linear extrude. Why am I not seeing it? Command F, linear. Okay, they're just calling it height. And all of these things don't really ever matter to us unless we're doing really advanced things. So I'm just going to call it height. Linear extrude height. All right, time for some XP. Should there be a semicolon? Quiet raised hand. Quiet raised hand. Do not give the answer away. Quiet raised hand. Should there be a semicolon at the end of this? James. Why? No? Okay, so you get a call on someone. Why does there not need to be a semicolon? You're correct. Oh, there is a... There it is, yeah. It's not an object. Linear extrude is a modifier. It modifies an object. Thank you, Monse. So Monse and James both get XP. What's up, Colby?
So then why do we put semicolon for variables?
So that's a good question. I don't have a good answer for it. I guess the way that I understand OpenSCAD code is modifiers are kind of like adjectives. So to make a sentence, you have an adjective and a noun, and then the noun would be the object. Variables are also a sentence in themselves. You're saying, hey, this happens, end the sentence, period, semicolon, go on to the next sentence. So the default is you have a semicolon. Only when you have a modifier do you not have a semicolon. All right, and then finally, the example. So you could do something like this. Linear extrude 5. And then you'd have something underneath this, like you could have a circle. I can't spell circle. Circle. And that circle could be a circle with radius of 10, semicolon. That will make a cylinder. This is another way of making a cylinder, and I'll show you what that looks like in a sec. So let me freeze the screen so you can write this down. So if I do linear extrude 5, circle 10, oops. All right, so here's a circle, and if I do a linear extrude before it, boom, it turns into a cylinder. It's that easy, and you can see if I actually render this before, it's definitely 2D, and when I get rid of that comment and I render it, it is definitely 3D. If anything looks green whenever you actually render it, that means that you have made a mistake. And by default, try not to render things until the very end. Be previewing because it goes way, way faster. All right, we're nearing the end of our notes. Let's see. We just did linear extrude, which is kind of an important guy. What else do we need to do? Oh, yes, modifier characters, color, and difference. Okay, so color, I can do that in like really, really quickly. And it doesn't really matter that much, but let's talk about it anyway. Color. Color. So when you're actually making objects and you export them as STLs, color doesn't show up on those STLs, only the actual object. So color is just for sake of being able to look at it. So as I was saying before, I was rudely interrupted by people trying to film. Color doesn't really do anything aside from make it look nice in the preview. If you actually render it, color won't show up. Color is really good for distinguishing parts. So if you have like a really complex object, make that all in red, and a really complex object, make that all in blue, and when you combine the two, you can see the two objects very clearly. So it does have a use, it's just not very useful once you're done with the object. So color, here's your example. You can do color, red. And there's a bunch of different ways to do color. You could actually use hex code, you can use a bunch of different things, but by default just use quotes, blue, red, cyan, I think that's how you pronounce it, stuff like that, and then you can do something underneath that like, I don't know, cube.
Wait, Mr. Sindel?
Yeah.
Is that a modifier an object?
Ooh, good question. And I will turn that into XP. Is it a modifier or is it an object, just judging by what I just wrote here? Modifier or an object? Cohen, go for it.
Modifier.
It is a modifier. 50 XP. And give 50 XP to Gunnar. It was a good question. Yeah, so, and we can see an example of this here. So if I do color, let's get rid of this, color, and I'll do red, and then I'll make that same circle. It's now a red circle. So you can make eyes that are black, you can do red, you can do blue. Blue is right there. It's pretty straightforward. Let's move on to the next slide. Again, get rid of all this stuff. Let me make some copies of this. Oh, what's going on? My computer isn't fast enough. There we go. All right, the next thing that we're talking about is difference. So this is probably the hardest thing that you will be learning today and it's something that people always ask me questions on even after I teach it. So if there's anything that you're going to focus really heavily on today, it's right now. Difference. How do you subtract one object from another? This is really subtracting, and I'll write this down as well. Subtract one object from another. That's the more, this still isn't very technical, but in a even simpler way I can say make a whole. So the difference command, it subtracts one object from another, or it makes a whole from whatever you want to make. And then you can actually choose what whole you're using, or what shape the whole is. So let me give you the official thing. So difference does not have any parameters. Again, parameters are those things that you go inside the parentheses. There are no parameters. It's just difference. And then we'll do some pseudo code here really quickly. So difference, and then you'll have main object, and then a whole. We'll say whole 1, whole 2, whole 3, etc., etc., etc. So you can, the first thing that you're doing is the main object. Everything after that will be considered a whole that you're punching out of that object. It's a super Falcon punch because it punches out perfectly. Let's see an example of this. So if I come back over here, let's get rid of all this difference. So let's say my main object is a cube, I guess. And we're going to make this cube, I don't know, let's make it 50 by 50 by 50. I guess I could have made that slightly different. What did I forget? Semicolon, of course. Can't type. Okay, so I have a cube. Let's zoom to size. So I have a cube, and I want to punch out, I don't know, what do you guys want to punch out of it? Should I do a hexagon?
A triangle.
A triangle? Okay, I'll show you how to make a triangle. Actually, there's a few different ways of making a triangle. So a triangle you can use, let's do a cool way. I can use a cylinder and make a triangle. Cylinder. So this cylinder is going to be, let's make it 30. So wait, a height of 51, so slightly bigger than 50, because the height needs to be slightly bigger than the height of the actual cube. And I'm going to make that cylinder have a radius, so I'm going to say, actually we'll say a diameter is equal to 30. So right now you might be thinking, okay, that's going to make a cylinder. How do you make that a triangle? Here's a cool thing. Remember that money Fn? That can be a parameter. That can be passed as a value, and I'm going to say that equals to 3. So there's my cylinder. I need my difference to have curly braces and my curly brace, and I'm now cutting off that object. So that cylinder, I'm going to put a percent in front of it so you can see the invisible cylinder that I cut. So if I want to put this cube in the center, I can of course do center here. And now it's cutting out perfect. Oh, center. Oh, it's true, not center. True. Now it's in the center, and if I maybe do this one centered as well, so I'll do this one, comma, it's going to be true, I believe. It's equal to true. There we go. So now it's perfectly in the center, and if I get rid of this percent, you can see that the hole that is being cut is indeed a triangle. So the main shape was the cube. If I want to punch another hole, I just type in another thing that's happening here. So maybe I want to cut, I don't know, a cylinder out of this. So I'm going to do a cylinder. Again, has a length of 51. It needs to be bigger, otherwise it's not going to cut all the way out of it. So cylinder, I'm going to call the diameter maybe even smaller, 10. I'm going to make it center is equal to true. And we'll make the smoothness really smooth, like 100. Semicolon, always forgetting this semicolon. All right, so right now you're saying, well, where is that, Mr. Sindel? And if I do the percent, you can see that it's in the center of the triangle. So if I want to move this, I can have an additional command in front of this. I like tabbing these over. And I can do a translate. I can translate within a difference, and I can say translate this, I don't know, let's move it in the x direction by, I don't know, 10, 10, 0, 0. And I'm moving the cylinder up. Let's move it up even more. Let's make it like 15. And if I get rid of this percent, it now cuts a hole right there. Oh, that's because I misspelled center. Pretty cool, yeah? So we're making multiple holes out of that same object. Within your hole, you can have translate. It doesn't matter what you want to do, but that's essentially how you do the difference command. Are there questions? This is the hardest thing you're learning all of today, the difference command. Does anyone else have questions about this? Edzeri, do you have any words of wisdom? Because this was our hardest thing when we were doing robotics. No words of wisdom? Okay, so the one thing that I will definitely add to the notes is the curly braces, because we forgot to put those. So curly brace there, and then you end down here with the curly brace. Make sure that you have these two. These are super important. I will circle them. These two are super important for your difference command. What are you taking the difference of? Do you get water? Okay. Make sure that you prop open the door with the trash can or something, because it's locked now. All right, and I believe we're basically there. Oh yeah, so modifier characters. So this is the last thing for our notes, and we're done for notes for the rest of today. Modifier characters. Characters. Modifier characters are super helpful for debugging code and showing you what's really going on. I was using them without even explaining. When I was over here in OpenSCAD, if I put a percent in front of this translate, it showed you where that cylinder was because it makes it invisible. But where did that percent come from? So let me teach you the basic parameters. And again, they're always in your cheat sheet. So where are they? Modifier characters are right here in the bottom left. So if you put a star in front of it, it will hide it completely. It doesn't make it see-through, it makes it just gone. It's like invisible. So if I come back here for the notes, this character, it doesn't delete it, but what did they call it here? It disables it. Disable. And what that really means is it's gone. It's gone. It's the equivalent of commenting your code out. So for example, if I came back to my code and I put a star in front of that first triangle, the triangle is now gone. Oh, it's gone. And if I take it away again, it's there. It's the equivalent of commenting it out, though, and putting a star. Okay. So what's the other modifier character? So show only. It's super valuable because if you have a ton of stuff and you just want to see what you're working with, exclamation mark, show only. So if I put this exclamation mark in front of, for example, maybe the triangle, if I put the exclamation mark, it gets rid of everything and it just says, hey, that's the triangle that you're dealing with. Or maybe I want to put the exclamation mark only in front of that cylinder. That's that exclamation mark. If I put the exclamation mark down here instead of in front of the translate, it does not translate it. It only does that cylinder. It only shows that object that I'm talking about. And then if I want to get rid of it, it goes back to that original object. It's really nice not to have to comment a ton of code out just to look at that one object. And I think next is I don't actually know the difference between hashtag, which is actually called an octathorpe, and the percent. So I know that this percent makes it transparent. So transparent. And I'm going to put in parentheses ghost. It kind of ghosts the shape. So if you put a percent in front of it, coming back to our example, if I put a percent in front of that translate, it will make that cylinder translate. It kind of highlights it, which was really valuable because if we didn't have that translate, if we can put a star in front of the translate so it doesn't translate it. Actually, we want to comment it out so it still has this in it. If I put the percent in front of it, we can see that it is exactly in the center of the object. Okay, so now it's coming clear to me. What is the difference between commenting out versus putting the star? If I comment out this line of code is still there. But if I were to put an asterisk in front of it, it treats both of these lines of code as one object, an adjective and a noun, a modifier and an object. Both of those are now gone because of that star. I don't know who's going to remember that, but that's kind of important. And then I'm not exactly sure I've never really used it, so we'll write it down in our notes. I don't know when we would use it. But this What do they specifically call it? Highlight/debug. Highlight. So let's see what it does. If I put a hashtag or an octothorpe in front of it, oh, it makes it red instead of gray, I guess. So that's the difference. So if I was doing a percent sign, then it makes it gray, and if I put a hashtag, it makes it red.
Yeah, highlights it.
Okay, highlights it in red, I guess. Yeah. Okay, so good to use. Yeah, that's it for our notes. Are there any questions? No. All right, so finally, with all of that, this is what we're working on today. You have about an hour to work on this. And hopefully it'll be small enough where I can print out everybody's. The 3D printer's officially, well, it's glued back together. I just need to put it back together. It's basically ready to go for today. We are creating a pencil holder for your desk, or you're making a cup for liar's dice. I prefer the liar's dice one because you can actually use it. Whenever we play liar's dice, you can like bring it in and have dice in it. But here are the specifications. The walls need to be 3 to 5 millimeters thick. So if I was actually drawing a diagram of the cup, a really bad diagram, this width right here, I don't know if you guys can see it very well, but that width is going to be 3 to 5 millimeters. If you make it 7 millimeters or 1 millimeters, that's not okay. 1 millimeters will be too flimsy. 7 millimeters will waste filament. So the walls need to be 3 to 5 millimeters thick, and they need to be uniform. This wall and this wall need to be the same. That means if that hole is not centered, then that's a problem. It also needs to be the same thickness for that base. This base thickness right here needs to be the same thickness as these walls. It's a little bit hard to do. You're going to have to do some math. Gasp. And make sure those are the same. You also... What's up, Gunnar? Oh, yeah, for sure. I don't know how Mathway is going to help you with this, but sure. Okay. You need your name engraved on the bottom. How do you do engraving? Difference will subtract text that's made 3D from a shape. So you're using everything that we've learned today. You're using text. You're going to linear extrude it to make it 3D, and then you're going to use difference to subtract that from your objects to engrave text. That's a lot of work, but I know that we can do it. You're going to have your name engraved on the bottom so that you know it's yours. And then finally, you need to use 2 variables. And the variables I have already named for you, height and diameter. And that will control the overall dimensions of your object, which is tricky because you should be able to change in any of these, and the whole also gets changed. So for example, let me show you something that is bad. So if I get rid of all this, let's do a difference, start my curly brace and my curly brace, and I'm going to start with a cylinder. And above this, I'm going to, do my smoothness, my number of segments equal to 200, so it's nice and smooth. So my cylinder now, let's just do an arbitrary height of 100, and my diameter is going to be set equal to, I don't know, some variable. My variable, I'm going to come up here, diameter, I think we all have to have diameter. My variable, I'm going to make that maybe 50. Ha ha ha, locked door. All right, so right now, I currently have this cylinder. Notice that when I change 50 to 70, it automatically changes in here because I have a variable at the very top. But the tricky bit is this, where I have a translate of another cylinder. This cylinder probably also has a height of at least 100, probably 101. And the diameter, actually it's going to be 100 exactly because it needs to be very precise. The diameter here is going to be diameter, well, let's just play around with it. Let's say it's 50. Notice that if I do this, we have this weird line thing happening. If that line thing happens, that means it is the exact height of the previous object. So I'm going to have to translate it up just a hair. So 0, 0.01. If I translate it up just a hair, that is now gone. And now it is see-through, but now the bottom has a thickness of 0.01. So to make this 3, I'm going to make that 3, and now the bottom has a thickness of 3. Notice now that when I change the diameter from 70 to 50, the walls change.
Whoa.
They changed in not such a good way. The walls are really thin here. The walls are even, oh, that would be too thick. The walls are thicker here. You need to have this set to that variable. Maybe diameter plus, I don't know, 6 or something like that. That way, oh wait, minus 6. I don't know why I'm doing plus 6. So that way when I change this variable here to maybe 80, the wall thickness stays the same. If this sounds like it's boring, I'm trying to give you the hint to the hardest possible thing that you're doing today, which is getting the math and the variables set up so that everything works based off of this one variable. Height is pretty easy. It's straightforward. Height, you just set that equal to like 100, and then come down here to cylinder and change that to height. And that works. So if I change the height now to 10, this makes it really, really not so big.
So how much inches taller does it need to be?
Yeah, I guess we should make those conditions right now as well. So I'm thinking about something kind of small because we usually play with 5 dice. So we'll probably go, let me use my caliper real quick, which is now put away. Is it? I don't even know where my caliper went. Is it still out here? Let's say that. People are annoying my class.
Can I have that seating?
Can you in like 2 minutes?
Yeah.
Let's say our maximum inner diameter is 50. So write it. Well, you don't need to write it down, but our maximum inner diameter, this has to be 50 or less. And our maximum height, let's do 70 or less. So this height here is 70 or less. This is all in millimeters. All right, this is the time where you ask questions. How do I do this and this? What do you think is going to be hard? What do you want answered right now?
Put the code back up on the board.
I'm going to erase that code.
Can we see it one more time?
No. Okay, there it is. And it's gone. All right, so no more questions? You guys have an hour. Let's see how well you can do this.